Okay, let's just dive right into this. Welcome to today's Explainer, where we're going to break down the exact culinary science required to successfully cook a notoriously tricky hybrid sandwich. I mean, we've all been there, right? You attempt a fusion dish, and you end up either completely scorching the outside or, worse, biting into a cold, unmelted center. No thanks. So today, we're looking at the exact physics behind the savory Monte Cristo hybrid and how you can pull it off perfectly. Now, this dish is a massive challenge because we're essentially fusing the savory, lipid-rich profile of a classic grilled cheese with that sweet, protein-heavy exterior of French toast. Fusing these two creates this intensely high-calorie, hyper-palatable carbohydrate matrix. But as you look at these competing profiles, it immediately sets up a massive clash of titans right there in the pan. Which leads us to this core question. How do we actually melt the cheese without burning the sugars? That's our fundamental thermodynamic challenge here. You see, the sugars present in the milk and egg wash, they're going to burn rapidly if they're subjected to the prolonged high heat normally needed to melt a thick layer of cheese. It is quite literally a race against time and temperature. So to solve this, we're going to treat this recipe like a strict lab experiment. Here's our agenda for today. First, the thermodynamic challenge, then protocol alpha, protocol beta, protocol gamma, and finally, we'll look at the red team report. Starting off with Section 1, the thermodynamic challenge, sugars versus cheese. Moving right along to Section 2, protocol alpha, the custard matrix. Okay, so the absolutely crucial point here is establishing this precise culinary ratio. You need exactly 1 large egg to a quarter cup, or roughly 60 milliliters, of whole milk or heavy cream. And listen, this isn't just a suggestion, it's a structural requirement. This specific 1-to-4 ratio perfectly balances the coagulated proteins, which means you get that signature, slightly crisp exterior without completely overwhelming the bread. But we aren't stopping at just milk and eggs. The real secret here? A microscopic dash of Dijon mustard powder, added alongside a pinch of kosher salt to balance out the cheese. This is literally culinary chemistry in action, folks. The mustard acts purely as an emulsifier to cut through the heavy lipid profile of the dairy. And because it's such a tiny, microscopic amount, it achieves this chemical balancing act without leaving any distinct mustard flavor behind. Pretty cool, right? All right, Section 3, Protocol Beta, Structural Assembly. Looking at our foundation, standard thin white bread is just completely unacceptable here because it's going to entirely disintegrate during the soaking phase. That makes a dense crumb bread absolutely mandatory. You really must use a structurally robust option. Think brioche, challah, or a nice thick-cut Texas toast so it can withstand the hydration phase we'll be talking about in just a minute. Now, for the core of the sandwich, you need a highly specific combination of cheese, layered between 2 dry slices of your chosen dense bread. You're looking for 2 to 3 slices in total. You'll want sharp cheddar to carry the flavor profile, paired strategically with processed American or Gruyere. And those are specifically chosen for their optimal phase change melting capabilities. Because, let's face it, you need both incredible flavor and that perfect molten texture. Let's move to the execution and see how this all builds together. Step 1 is layering your dry bread and cheese. But step 2 is vital. You must press the dry sandwich firmly with the palm of your hand. What this does is it compresses the crumb of the bread and creates a slight physical seal right at the edges. This mechanical seal is absolutely essential because it prevents the liquid custard from aggressively seeping directly into the cheese layer when we go to dip it. Which brings us to Section 4, Protocol Gamma, the thermal phase. First up, the submersion. You must briefly submerge the assembled sandwich into the custard matrix for exactly this window, 5 to 10 seconds per side, period. This is a hard limit. If you let it soak for any longer than that, the internal structure is going to take on way too much liquid and collapse entirely into an unappetizing, gummy paste. Nobody wants that. Next, we've got to control the heat, 300 degrees Fahrenheit or about 150 degrees Celsius. This specific temperature is noticeably lower than standard grilled cheese cooking temperatures. You need this exact temperature as your required heat buffer, utilizing a non-stick skillet prepared with exactly 1 tablespoon of melted butter. All right, now we get to the actual cooking sequence. Step 1, you cook it for 3 to 4 minutes until the bottom is deeply golden. Step 2, you flip the sandwich. And step 3 is by far the most critical. Immediately place a tight-fitting lid or a metal mixing bowl right over the sandwich for exactly 60 seconds. We call this the steam dome. It brilliantly traps the residual steam that's evaporating from the egg wash, forcing that convection heat directly into the core of the sandwich. This melts the cheese rapidly without requiring extra time on the hot pan, meaning your bottom slice is absolutely safe from burning. To finish the process, you just remove the dome and cook for one final minute. This final step simply evaporates any lingering surface moisture from the steam dome, ensuring you retain that slightly crisp exterior right before you pull it off the heat. Now for Section 5, the Red Team Report, the pre-grill method. For a totally complete picture, let's impartially look at a counter-analysis. Some culinary thinkers out there like to play devil's advocate and argue for what's known as the pre-grill method. They argue that to prevent the bread from turning soggy and to ensure a perfectly dry interior, you should actually cook a standard grilled cheese first. Let it cool completely so the cheese resolidifies into a waterproof barrier, and then dip the entire pre-cooked sandwich into the egg wash and fry it a second time. I mean, it sounds like a foolproof hack, but let's objectively look at the scientific trade-offs here. While the pre-grill method absolutely does create a dry interior, consider the physical trade-offs of this double cooking process. It completely destroys the structural integrity of the crumb, drying it out severely. Furthermore, forcing the cheese through multiple thermal phase changes, so melting, cooling, and melting again, often causes the milk fats to split. That means you're left with a greasy, separated mess inside, rather than that perfectly unified molten core we achieved with Protocol Gamma. Finally, we really have to consider the sensory expectation here. A traditional Monte Cristo relies heavily on Western culinary standards of the sweet and salty bliss point. So our final question to you is this. Considering the traditional addition of powdered sugar or maple syrup as a topping, are you brave enough to cross that sensory boundary? Or will combining this highly savory, lipid-rich cheese with a sweet syrup just be aggressively jarring to your palate? It's a truly fascinating clash of flavor profiles to ponder as you master the culinary physics of this incredible hybrid dish.